Welcome back. Now let us do the hands-on of the random forest. And there have been at least few libraries which implement the random forest. And I have worked with many, and I find that Ranger is the fast implementation of random forest. And it is a stable library, and I have used this in a project, and it works quite well. Line 41, we are reading the data of fresh, and line 44 we are changing the data types to factor. Categorical column we know very well. Line 47 onwards, so we are segregating our train and train data in a train and test. Train is around 85% and the test is around 15%. Line 54 we are importing the Ranger library, and again just to let you know, there are many library for the random forest. This one I have found it out a bit stable, very fast compared to other. And if you find something other better, definitely you can use it. But here just try to learn it how to use the random forest, because implementation may be different, but the concept and the way random forest work is same across the library. In line 56 we are getting list of the predictor variables, and line 57 we are creating the formula. So if you see this formula, I'm just trying to print it. So it is saying a dependent variable is a species, and these are the 4 independent variable. That is what it depends upon. Okay, and so it is saying, see, random forest, another good advantage of the random forest is that it has the minimum number of parameters to train for. So here you have to minimum to modify. And I hope you recollect, in case of XGBoost, we had almost 5-6 which we saw, and when you see that documentation you'll find another 15 to 20. So it's not necessary you have to modify all of them, but at least 5 to 10 is definitely you have to modify in XGBoost to get the better accuracy. In case of random forest, the number of parameters which need to be modified is minimal. This is what I like in random forest. So if you see that random forest, we are using only 2 parameters. And first of all, let me explain this mtry, and let me show you that what is the value it gives. Okay, mtry 3, number of tree 500. So this number of tree, the 500, it is this number of tree that if you see, this is that 500. And if you want to know the few more things like what is the various other parameters and all, so you can see the documentation. And this, how to see the documentation, click the place where you are and then click F1. So I have put the cursor on the Ranger and click on F1. So it will be coming, it must be coming. So why it has not come? Oh, it has come. Yes, it has come. Yes, so it is going to show me the okay. So this number of this is having at least all of these things, but few things are only important. That number of tree and the mtry is a number of variables that must be split in each of the node. So and so here what we had done it. Here we had done, if you see the mtry, number of features. So if you see that we had a total number of features is 7. If you see, this is the total number of features. So we have 5, and if you take the square root and take the upper part of this, that is coming around 3. So what it is saying is that when you're trying to make a subset, like this is the subset, when you try to make a subset, take the minimum number of 3 is 3. Minimum number of columns is 3. Okay. So that is what. And here I was showing where, yeah. So there are a few more things are there, but you'll find that not many of these things are useful. Although you can definitely look at the documentation, but not many of these things are useful. So let us proceed. And random forest can also work in a multi-core, where it can work in parallel, and that is what we're giving number of threads, and this is giving the number of cores on your laptop. So in my laptop it is 4, and generally it is useful in case of server where the number of cores are very high. So line 69 just giving number of cores, line 71 just hard coding the number of row and the column so that we can print and make it nice. So what it says that we are going to work with 129 rows and the 5 columns, and these are the parameters we are going to work. Okay. In line 76 we are fitting it, that is the training. So what a training takes, it is taking the formula which we defined earlier. This is our data, this is number of tree which we have defined here. M try we defined above, number of threads also we have defined above. Right forest true, that I'll explain a little bit later. Importance purity, there are 2-3 ways to find it out, the importance of the feature, and I had also shown this one in XGBoost. So this is the one, and this is saying classification true. Yes, it means we are using it for the classification, and so that's all. Line 76 we are training it. Okay, it has not run library. Okay, it should run now. Yeah, it has done it run. And this is the way you can save the model so that you can use in future. Line 77. Okay, and now we are doing the self prediction. So this is for the self prediction. Self prediction, line 80, and the value you want to see in line 81, you're just trying to see the value. This is the value of the self predictions. Okay, and in case of classifications, we had also discussed how are we going to see the accuracy of it. So we are just trying to see the accuracy, line 84. This is the function I have written in common util, and let us see that what it is giving. So if you see the classification accuracy is giving the confusion matrix, and if you see the confusion matrix, it is 100%, and you know why it is 100%, because this is the self predict, that prediction on the train itself. Okay, prediction on the train itself. Kappa is also 1 perfect, accuracy is perfect, everything is perfect because this is on the train data. So that is why it is almost all the data are perfect. And okay, now let us go and see the importance matrix. Important matrix is I hope you recollect we had seen this one in XGBoost as well. So let us go and get the importance matrix. Just trying to order it so that we can print it with the maximum information. And this has been printed in the model folder with ranger importance.csv. So let us go and see in the model folder, ranger important.csv. Yes, this has been printed. So what it is saying that this feature fatal.width is getting around 46%, petal.length 37%, sepal.length around 1%, and sepal.width is around 0.6%. So this is what the this is all about. And if you see the sum, it will coming around 100. So it around 10-15% is somewhere else, or probably I'm unable to recall on top of my mind that whether it has been normalized or not, or it is giving the percentage. So I'll look into this and I'll put it on the discussion forum. But you can also look into the documentation, what is the meaning of this. Okay. And this was for important matrix. Line 92 we are cleaning it. Line 95 onwards, we are going to work on the test data. So we are going to work on the test data that is having around 21 row and 5 column. And this is the prediction on the test data. So the data have been predicted. Line 100, we are generating the classification summary on the test data. And this is worth discussing because test data is not seen by the model. So if you see that this is making one mistake, all the diagonals are the correct data and non-diagonal data is mistake. So this is the mistake. This is also mistake. So if you see that accuracy is around 94%, kappa is around 8.85%, and okay, it looks good. So okay, and that's all. And here we are doing the cleanup. 100.03, we are doing the cleanup. So this is all about the random forest, and I'll request you that if you have any question or if you have not understood anything, please write your question on the discussion forum and I'll be happy to reply you. Thanks for watching it. See you in the next one.